Alright, so this is our second video, and our second video is now looking at the actual polar paper that you're going to be using, which is the same as what you've used in your past labs. A couple things about your setup. You're going to be using a semicircular glass piece. Now, when you position this on the polar paper, it's really important that you position the flat side here in line with the 0 mark, right? Because that's going to be your starting degree, so you want to make sure that's lined up on both sides, and on the other side it's going to be 180 degrees, right? Because it's going to be 180 degrees all the way around. So just like a protractor, so you want to set up the flat side of your glass piece so that it's lining up at 180 on the one side and 0 on the other. The next piece you want to make sure, if you look at the glass piece here, it fits right within the grids. It doesn't slide from one side or the other, so there's equal spacing here, equal spacing here. Once again, that sets it up so your piece of glass is centered right at the open spot in the middle of the polar paper. So that's your first part of your setup. Now the second part of your setup, once you have this established, is now then moving or taking this polar paper and now shining a ray box to the center of the glass. So I'm just going to move this around. Alright, so you will take, again, I'm just going to make this line a little bit smaller. Alright, so you're going to have your incident ray, so it's going to follow one of these lines. So I'm going to follow that right down. It's going to hit the middle. So that would be your incident ray. Again, your incident ray is going to be measured from your normal. So remember, we're going to find our 90-degree mark here. So this is my 90-degree mark. That is now my normal. So it is this angle here. That is my angle of incident, or incidence. When we measure that, then what's going to happen is from that point it's now going into a different medium, which is the glass. And so now you will take the refracted ray, which you may or may not see right through the glass, but you definitely will see it exit the glass. So it's going to go from here, and it's going to then follow a different line out. Now, the angle refraction, again, needs to be compared to the normal. So I'm going to continue the normal down. And so this area here is your angle of refraction. So you need both of those because you will be looking at ratios of your angle of incidence to your angle of refraction. They need to be measured properly, because if you don't, then you will not get the right outcome for the lab, and it's going to be really frustrating in the end because you won't see the pattern. So remember, angle of incidence is measured from the normal, right? Normal to your incident ray. Your angle of refraction is from, again, your normal to where your refracted ray is. So you can use the polar paper to figure out that, and then you would record that information. Now for this particular lab, you will continue and you will move your rays around. So you'll take one incident ray, say at the point that I showed you with the blue here. Then you would move, and then you're going to look at another incident ray. So then you move it over 10 degrees. And then you're going to then measure that once again. This is your angle incidence. And then you would look at your corresponding angle of refraction. And then you would measure that. Now, definitely sometimes it's difficult to see the angle of refraction. So sometimes you can put a screen here so you can actually see where the light hits, and then you can trace that light back to where it leaves the glass. That can work. Or you can just look exactly where it's being reflected off the glass as it leaves. That's another possibility as well. But taking really precise measurements is really key to this, because again, you are looking for a ratio. So in the end, what you'll do is during class, you'll be going to Google Classroom. On Google Classroom, there is a worksheet. One's called Optics Lab number 3, and one's Optics Lab number 4, all in the same file. You're going to have access to Google Chromebooks tomorrow, and as you're completing the lab, you're going to be writing your results in the table that's provided, as well as you will answer the analysis questions as you go through. So that's why it's so important that you review this video and you have a good understanding of what's happening in the video, so when you come into class, you can start right away and start recording your information. Now, some of the things that you'll be recording, or some of the things that you will have to calculate rather. One is looking at angle of incidence over the angle of refraction. And you'll be given a number. So say, for example, it was 30 over 15. Then you're going to take that, and then that's going to equal 2. No unit with that, you're just looking at a ratio. If you're looking at, for example, the other ratio you're going to be looking at is, just give you an example, you might have the sine of 20 degrees over the sine of 30 degrees. Now, you know what, I'll give you a better example of that. Just a second here. Let me just erase that, because that's not exactly how it's going to be looking in your data table, so I'll just clarify that. So you're actually going to have the sine of your angle of incidence, that's what it's going to look like. Then you're going to have the sine of your angle of refraction. So then that's going to be your sine, so whatever you measured in your lab, so say that was 30 degrees, and then you're going to divide that by the sine of, say, 25 degrees. Now you can try this in your calculator. So all you're going to do is type, or find your sine function, type 30, and that's going to give you a decimal. So in this case, if you're doing it correctly, you're going to get 0.5. Then you would do the same thing, sine of 25. In that case, you're going to get 0.423. So I'll just keep it as that. And then you're going to divide those. So you'd go 0.5 divided by 0.423. And so then that ratio would be 1.18. So again, those are the two types of ratios you're going to look at. You're going to be looking at the trend of your actual angles, right? So in this case, this would be 30 degrees over the 15. Then you'll also be looking at your sine function angles. So again, this is trigonometry. So this is going to give you a decimal. So it's eventually going to give you this. You're going to divide those two, and then that's where that 1.18 is. And again, there's no unit attached to that. That's just a number that you're going to record in your chart. And then again, it's those numbers that you can use to look at trends that are happening with your angle of incidence and angle of refraction. That's pretty much it that you need to know for the lab. Again, all that information will be recorded into Google Classroom, and there will be a worksheet on there that you can use and type into. You'll be working on partners, so you can just submit one per partner. That will work out fine, and then that will be a great introduction to the idea of refraction for you. We'll see you tomorrow.